We mentioned graphs and models. Particular topics, the slope-intercept form of the equation, which we've had already, and some of you may remember, was equation 2, and we'll be repeating it a few times here. Y equals mx plus b, where b is your y-intercept and m is your slope. It's a very important equation that we'll be studying in this section. So here they're giving it to us now in function form. So the function form is f of x is equal to mx. Now if it's in this form and there is no y-intercept, we can think of it as plus 0. That would be the letter B normally there. But if it's not there, it's a 0. That means it's going through the origin. 0, 0. And again, for this function part, we could always substitute a y. Now, if we have this same formula, f of x is equal to mx, and there is now a value in the b position, that means this graph, whenever we make it, will go through point B, which we said a number of times is our y-intercept. Okay? So when there's no b value, it goes through the origin. When there is a b value, the y-intercept, that's where it goes through the y-axis. And again, this point, 0, b, is by definition called the y-intercept. This is sort of the official form for it, but sometimes they just put b equals 5, and that would be 0, 5 in a sense. Okay, something easy. Think about what they're asking here. For each equation, find the y-intercept. Well, here's our formula. Y equals mx plus b. Now, whatever's in the b position here, that will be your y-intercept. And you could say b equals 3 or b equals 0, 3. You have to see which way they want it. On a test, I will accept it either way. So they're giving it to us in both ways here. There's your b in the y-intercept form, or simply b equals 3. And there's your b there. And again, two ways. Now keep in mind the negative goes with the 8. All right, now when we look at slope, and we did a little bit of this earlier, we said there was a special formula for slope, and we had given you that as this here. M equals, it was this one that we used. Now notice you could switch the positions of the sub 1s and the sub 2s. Try to stick with one, that way you won't get messed up. And once again, what is slope? Well, it's a ratio of rise units, which are y units, over x units, which are run units. Remember, vertical change are y units. Horizontal change, x units. Rise over run. Now, this is going to be important when we get ready to graph these. There's a very interesting technique that's used, and we'll show you that as we go on. So, let's get this set up in a way we can follow and put in our notes here. So what's the formula? Well, the formula is M equals y sub 2 minus y sub 1. Remember, we said this was formula number 3 on our list of formulas. And here, x sub 2 minus x sub 1. Now, it doesn't make any difference which ones you designate as the sub 1s and the sub 2s. What they showed in the other one, you could switch them around. But try to stay with one way, and that's how you always do it. So I always say the second set of coordinates are the sub 2s. So I take this first member right here, negative 1, which is my y sub 2, negative 1. Now there's a negative in the formula, so I put that there. And then I go to my y sub 1, which is 5. Then I go to my x sub 2, which is down here. That's 4. Now this is tricky. It's minus, which is in the formula here, but 4 is a negative. So it's going to be negative 4. Now, when you have the opposite of a negative, this is an interesting case where whenever you run into that, it's going to make this a positive. The opposite of a negative is a positive. So what do you have? Well, you have negative 6 over a positive 8, which reduces to a negative 3/4. And that is your slope. Now these are rise units, these are run units. So again, they're showing you step by step, change in y, change in x, rise over run, and if you were to plot it on a graph, you'd have this point here and this point there. Now, another way, by the way, if you have a graph that you can use to actually figure out the slope, is look at a point where it's crossing the grid right there, and it's crossing the grid right there. It's also crossing the grid right there. We'll do this one later, because there's a triangle, and there's a bigger triangle. So this is the ones they gave us. So now what we're going to do is count, and we're starting here. We're going to count number of rise units, and we're going down. So this is going to be 1, 2, 3, 4, 5, 6. So this is a negative 6 for our run. I'm sorry, rise. Apologize for that. Okay, let's do our run. Now we're starting here, and we're going in a positive direction. So 1, 2, 3, 4, 5, 6, 7, 8. So our rise of negative 6 over a run of positive 8. Well, can you see that's a negative 3/4. Now notice it also crossed right there. How about if we do this one? Well, here, let me see, I lost my line. Okay, there it is. 1, 2, 3. That's a negative 3. 1, 2, 3, 4. That's going to be a positive 4, which is again a negative 3/4. So slope is consistent even if you make it a bigger triangle. The key is you have to count where it actually goes through the grid lines, otherwise it's off. So 6/8, 3/4. That is our slope. And interestingly, since we counted down here, when it starts high on the left, and as you move to the right, it goes down, that is negative slope. We'll review that again too. And that's what they're showing. And there again. So as you simplify, those are your slopes. You always put the slope in lowest terms. Okay, now this is a super important technique that we will be using. They want us to graph this equation in slope-intercept form on this graph. So the first thing we do is we plot the y-intercept, which is a -1. So we go over here and put a dot on -1. Second thing we do is we put the slope in from that particular point. And remember, it's y units over x units. And it's positive. So my strong suggestion is plot the y value first, the run. It's positive from this y-intercept. So there's our y-intercept, and our run is 3. So 1, 2, 3. You can put a little dot there, but that's mental. There's not really a dot there. And then we're going to plot our rise, our y units, which are 2. Go right there. So now we have 2 points. So when you do this in MATLAB, you're going to get your arrow tool or your line tool, click it on the y-intercept, go over 3, and then up 2. So right there, and I'm just doing that here. Let's see here. And you can extend it down this way too. And there is your graph. Now, when you do it using your line tool, dot there and a dot there, and then the whole line forms. You don't have to stretch it out like I have to do. Okay? So once again, you've made a little triangle to this point, in a sense, and then you've gone up 2, and these little right triangles. Now, by the way, if you remember from your geometry, this distance from here to here is the hypotenuse of that right triangle. There's a little right triangle right there. Okay. So first thing you do, plot your y-intercept. Now they're doing it a little differently. They're going up 2. If that's the way you learned it, and that's good for you, fine. I always like to do my run first. If it's positive run, I go to the right. If it were negative run, I would go to the left. And you'll have some on that as well. Again, I do this one. You get the same second point. But again, stay with one way to do it. and then you draw your line. Remember, there's an arrow on the end of each side indicating it goes on to infinity in those directions. So we say an equation in this form is, as we've reviewed a number of times, the slope-intercept form of the linear equation. Right there. And there is its official title. So when you are graphing something that is in this form, once again, you plot your y-intercept. Then from that point, you plot the slope, starting with the run and then doing the rise. If it's positive, it's going to go this way and up. If it's negative, it's going to go this way and up. And again, this would be negative slope, and that would be positive slope. Okay, now they're asking us to find the slope and y-intercept of each line. Now notice the first one is very easy because it's in slope-intercept form. So our slope will be 3/8. Our y-intercept is a -2. Now in equation B, this is in standard form. So to find out what the slope is, we have to put it in slope-intercept form. That is, you have to solve for the letter y. Now we'll do that by transposing the x to the other side. It changes its sign. And now we have it in slope-intercept form. So our slope is going to be a -3, and our y-intercept is +7. Now, again, there's a couple of ways to solve for y in letter C. I like to keep my y's positive, so I'm going to transpose the y to this side, which is okay. Now it's positive. And I have to transpose the 10 to this side, where it becomes negative. Now I'm going to divide everything by 5. And I'm going to rewrite it so the y is over on this side. So this is just plain y. Now this is 4/5 x, and this is a -2. Now that I have it in slope-intercept form and my y's are positive, I now can identify my slope as a 4/5 and my y-intercept as a -2. Now, they don't ask for this, but what I'm going to do now is graph each of these equations using the technique we just showed you. Now, what I'll do is sketch these because I don't have graph paper. So I've made my set of axes. First thing I'm going to do is plot my y-intercept, which is -2. 1, 2, I put a dot right there. Now this is a slope of 3/8. So I need to go over 8 units for run. 1, 2, 3, 4, 5, 6, 7, 8. Now I have to go up because it's positive. Up now 3 units. 1, 2, 3. And there's my point. And there's my other point. I'll make a line through this shortly. All right, here my y-intercept is 7. So I go 1, 2, 3, 4, 5, 6, 7. I put a dot there. Now my slope is a -3 over 1. So since it's negative, I'm going to go 1 unit this way, and my rise now is 3. 1, 2, 3. So there's my line. Now for this one, my y-intercept is a -2. 1, 2, a dot there. And my slope is 4/5, positive. So I'm going to do my run, which is my x units. 1, 2, 3, 4, 5. And now I go up 4. 1, 2, 3, 4. And there's my second point. And now I just connect it with a line. And there's this one. And for this one, and you usually, well, in your math lab, it's going to make it the whole graph. Now remember, you'll be testing on this, and I'll give you a straight edge so you can make some nice lines. But as you do your homework logs, use a straight edge of some type so your graphs look nice. And practice this technique as often as you can. It's going to be very useful for you. And we've done all of this. Again, you have to convert this to slope-intercept form. And there it is. And then the last one, again, slope-intercept form. And there it is. Now, notice they had to divide here since they kept y on this side. You have to divide each term by a negative. Okay? So dividing this by a negative, that's where it makes it a positive here. Again, they did it a funny way. I wouldn't do it that way, but different strokes. Okay, this one's sort of easy. Read it carefully. And what tools do you need? Well, you want to know what slope-intercept form looks like. Y equals mx plus b. Well, they want us to write an equation, so we put our y, but here they're telling us what the slope is. A -3/7. Notice they didn't do that very well. I want our little bars here to be horizontal, and we put an x there because that's part of the formula, and our y-intercept, we only write the 8. And it's just that easy. If they give you the slope and they give you the y-intercept, it's just putting it into formula 2. And there it is. I remembered one time when I was doing math lab, and it was a problem similar to this, and I said, oh, I know the answer. So I put y equals that. But they already had, in like part of the answer block, this. So I had y equals, and then they counted it wrong. Well, I had it right. Again, you have to read the instructions carefully and look at it. I tend to go a little bit fast, and that's a problem I'm still working on in my later years here. Okay, once again, we're going to practice graphing this. So what strategy do you use? Well, they gave you the y-intercept, and they're giving you this positive slope. So step 1, plot the y-intercept, a -2. Then, since it's positive, we're going to do our run first. So 1, 2, 3. And again, you do this mentally, and you're going to go up 4. 1, 2, 3, 4. And there's your right triangle. There's your run. There's your rise. You're going to click there, and it makes a nice line for you. And then that's your graph. Okay? Do your y-intercept first, then your slope. If it's positive or negative, if it's positive, you do the run to the right. If it's negative, you're going to do your run to the left, and then you rise. And notice that line is just the opposite here. So they're plotting the y-intercept. Again, they're doing it a little differently. That's okay to do it that way. You get the same answer. And then you put your line in. Now, keep in mind, you can also start at this point, go down and over this way. So it's different strokes for doing it. Okay, now they're giving us a formula in standard form, and they want us to graph it. So for y, we want to solve for y. So we're going to transpose the x term. Going to the other side, it just changes its sign. We're going to divide everything now by 4. This becomes y equals a negative 3/4 x plus 3. Now to sketch it, positive 3, 1, 2, 3, a dot there. Now notice it's negative, so I'm going to do my run of 4 to the left. 1, 2, 3, 4. Now I do my rise, 1, 2, 3, and there's my graph. Okay? So again, when it's in standard form, you have to solve for a positive y, transpose that, changes its sign, divide each term by 4, and you then get it. Now the thing is, we haven't really had equations or a review of equations. That's coming in our next little section here, but some of these are pretty straightforward. Okay, so from this point, it's easy to graph. Put in our y-intercept, go over 3, I should say go over 4, and then up 3. Yep. Now you could have done it this way, down 3, over 4. There's a lot of different ways. Try to stick with one way so you don't get messed up. Now, what do we use graphs for? Well, they're very useful in helping us to visualize certain things. So for instance, just looking at this graph, what's the trend? 4, 5, 6, 7, 8. All right. So here we have Wanda's hair salon, and this is a graph of what she's done. Can you see the trend is rising? Here, these are the number of haircuts completed, and these are hours in the day. So let's take a look at it. We can find the rate, that is the number of haircuts per hour, and if you just go, let's say, from here to here, notice in this 1 hour here, this is 1 hour, that's 2 haircuts. Okay? So she has a rate of 2 haircuts per hour. Now in this example, they're saying Swanson Electronic uses the function this to determine the salvage value of a delivery van after this purchase. So what do the numbers negative 2,500 and 12,500 signify? Well, notice this is in slope-intercept form, where it's function. So this is the slope. T is sort of for time. And this is your y-intercept. This is where you're starting. So initially, this was the value of it. And since this is negative slope, that means the value is decreasing each year. So let's take a look and see what they show us. So there's the 12,500 right there, and it goes down to 5. So it's saying the number of years that this is useful, according to this formula, is 5 years. After 5 years, its value would be 0. And again, it shows what they call depreciation, that through time, something depreciates in value. You buy a brand new car, it's worth $25,000, and then in how many years will its value end up being nothing? Usually it doesn't go quite in a straight line. It kind of like toward the end of its life, it kind of curves out a little bit. But here again, remember a straight line graph is linear, and that's what we're illustrating. So again, this is what it decreases in value each year. And this represents the value of the van when you started. That's your y-intercept. And it will be completely depreciated when time is 0. And it's right there at 5 years. And that's what they get. If we wanted to write the domain of this, by the way, in roster notation, we say T is such that T is greater or equal to 0, T is less than or equal to 5. And that's what this graph shows. Our T values are right here. And that's what they're showing. T is where I have the red line, and that's domain. Okay.